Welcome everybody to the start of the Cellular IoT Developer Program. I slowly see people joining in, so we're gonna wait a few more minutes before we officially kick off the presentation. Some information to get started. There's a chat feature and there's a Q&A feature. And would love you to use it. If there are any questions during the presentation or during the webinar, you can really add those questions there and we'll be addressing that near the end of the presentation. So yeah, to get started, feel free to type a message, say hi, and let us know where you are from, because we love to learn who we're talking to. So maybe it's good to already start with a short introduction while we wait for, let's say, a few more minutes, allowing others to join in as well. So my name is Lawrence. I'm the developer community manager at Monogoto. And with me, I have Amir Benjamini from Origin GPS. So maybe you want to say a few words.
Nice to meet you, everybody. It's a very pleasure to meet you. As Laurent say, we would love to know where you're from. Tell us all about you, what you are going to do with the information that we are sharing with you. So start everything and write over the chat whatever you want.
Perfect. Nice. I already see some people joining in. Hi, good meeting you, Ronald, all the way from Colombia. Jakub from Poland, Arizona, Canada. So myself, I'm based in the Netherlands, in Amsterdam. And Amir, I think you're based in Tel Aviv, Israel. Is that correct? So it's truly a global session. So I'm really excited about that. So, okay, let's kick off. I'm really excited because this is the first of a series of 4 workshops, and it's all about cellular IoT fundamentals. And throughout the upcoming months, we're gonna show you, we're gonna tell you how this works in theory, but the part that I mostly like is that we not only gonna tell you, but we also gonna demonstrate, and we even allow you to go hands-on during this development program. So let's have a look. So to give you an introduction about the developer program itself. So today we want to focus on giving you a good foundation of knowledge to understand cellular IoT fundamentals. And from this foundation that we built, we're going to dive in a more hands-on part next week, where we're going to go through the whole process of building an IoT end-to-end application using cellular IoT connectivity. And the week after, we go one step further and we dive into the low power modes of IoT devices, because almost all devices, they run on batteries, and you don't want to charge your battery every other day. So you need to manipulate, you need to alter the settings to make it run for months or even years. And finally, the last week of this developer program, I invited Ubidots to help us with presenting about how to integrate and how to act on IoT data. And there we are highlighting the process from sending a packet using UDP or TCP, HTTP, or even MQTT to forward it to the cloud and basically work further from there. So we already started briefly. So my name is Lawrence. I'm the developer community manager at Monogoto. I've been in the IoT space for quite some years already. So actually before joining Monogoto, I was more focused on unlicensed IoT and mostly on LoRaWAN technology. So in that sense, I can also give the comparison with cellular IoT technologies. And Amir Benjamini, VP of R&D at Origin GPS. So really happy that Amir is joining in, because he's not only able to talk about it, but he really has the hands-on experience that you need for building an IoT solution. So he can really talk from experience and give some really nice examples on how this technology works in practice. So the agenda for today. So I'll kick off. I'll give a bit of an introduction to cellular IoT. I'll explain what it is, what are the essentials, and I'll dive into the evolution of wireless communication. And then I'll give the floor to Amir, and he will explain about LTM applications. And he mostly focuses on LTEM, so he'll explain more later why he focuses on that technology, highlighting different features, diving into hardware, and then explaining some interesting use cases. And then finally, we are diving into networks and coverage, and I'll give you a bit of information about Monogoto itself, and then we end up with some questions and answers. And we're trying to keep everything within 1 hour. So moving on, there's actually a very nice announcement that I'm making here. And this is not only the start of the developer program, but this is also the launch of the Monogoto community. And with that, I mean that we are trying to bring IoT developers together to really jointly help each other realizing IoT use cases. So for doing so, we also set up our forum. So I would warmly invite you to have a look, to sign up there and to engage in conversations with other IoT developers, to help each other bring IoT to the market. And I made sure that the whole expert team of Monogoto, they are ready and fully available to answer any difficult question. So feel free to engage, to ask questions, or to share your work on this space. Practical thing for this presentation, everything will be recorded. So we might flood you with information during this presentation, but you can always rewatch it later. Starting with LTE evolution, and actually moving all the way back to 1991. And that was the period when 2G was initiated. And there's still a lot of 2G networks available as of now, but this technology is really old. And about 10 years later, 3G technology hit the market. And around 2008, 4G technology was introduced. And actually, in 2008, something really interesting happened, because LTE in itself, that's not one technology. Instead, it is a group of technologies that we all call 4G or LTE. And in 2008, the 3GPP, which is the alliance that works on the specifications of cellular IoT or of cellular communication, they made the separation between what we call MBB and MTC. And MBB stands for mobile broadband and MTC for machine type communication. And the difference is that MBB focuses on large bandwidth, high throughput, low latency, allowing you to watch YouTube, stream Netflix, or to listen to Spotify, which consumes really lots and lots of data. And popular categories are category 4, which was announced in the release 8 of the 3GPP Alliance. And actually you see all those category numbers going up. And I know we have category 18, and now they're already somewhere in category 20. And these numbers, they're only going up. And in the other end, you see machine type communication. And in contrast to these large bandwidth technologies, you see that these technologies are more designed for machines, and machines don't need to stream Netflix, but they only need to send data occasionally to the clouds. And for that purpose, then you don't need these very heavy chips that consume a lot of resources, which is both budget and energy consumption. Instead, you want something small that you can embed on a PCB. You want something that consumes very little data, so it can run on batteries for years. And that's where these MTC type communication fully focus on. And by 2016, in release 13 of the 3GPP, two very interesting technologies hit the market, which are LTE CAT-M1 and LTE CAT Narrowband 1. And these are also referred to as LTE-M and Narrowband IoT. And this is really those were the promising technologies that we see now slowly appearing in the market that really live up to that promise of low-cost modules, very energy efficient, and very suitable for IoT use cases. And a year later, in 2017, we even see the next version of these technologies appear. So we now also have LTE CAT-1Bs, which is actually very similar to LTE CAT-1, but they removed one antenna that allows it to be even more cheaper and smaller to embed. So there's some small changes, and the same applies for LTE CAT-M as well as narrowband IoT. But I have to say here, those novel technologies that you see at the far right, the specifications are released, but those are not widely adopted yet. So during this presentation or during this developer series, then this is what we focus on. So mostly LTE CAT-1, LTE-M, and narrowband IoT. And that's what we call cellular IoT. So when talking about cellular IoT, then you often have these types of criteria. So devices, like I mentioned, need to be low power because they need to run on batteries for multiple years. IoT devices often come in large volumes, so they have to be very price competitive. Devices are often installed in remote and hard to reach locations. So the range, or what we call link budget, need to be really good, often much better than these mobile broadband technologies. And also something good to consider is that coverage is essential for many of these IoT use cases, because we're working a lot with tracking or mobile devices. And often these devices need to be operational in multiple countries or even worldwide. So it's good to consider, okay, so to what extent does my IoT solution need coverage, and do the technologies that I want to use, do they provide that? Same for mobility. Not all IoT technologies support mobile devices. And it's also good to consider, okay, so what is the data throughput that I need to have for my application? And it also depends on the technology that you choose. And to give you some examples of IoT use cases that we see a lot in the Monogoto platform is we see lots of things happening in agriculture. Livestock monitoring is actually quite a big use case. And you see these cattle have a collar around their neck, and that tracks the location as well as the body temperature of these animals. And you can even create, let's say, a personalized profile for each cow that you can even sync up with the milk production. And in that sense, have like a full picture of each animal. And by having all this information, then you can easily detect anomalies. So if an animal is sick, or you can find the fertility of these animals over time. The most popular use case that we are seeing, at least on our platform, is based on asset tracking, which is tracking valuable goods. And here it's really important, like I mentioned, that the coverage is an essential part of these use cases, because often there's a tracker on valuable goods within trucks that cross borders, and then like you want to make sure that your device is still running once you cross the border. So we see lots of asset tracking applications. Smart street light, there are no street lights being produced anymore without wireless communication modules. And most of them contain SIM cards, either plastic SIM or embedded SIMs that you soldered right onto the PCB. And that's actually a very popular use case. And finally, we see quite an interesting development in point of sales, and which are kind of the payment terminals that you use in shops. And they always need to have a communication module, and they also don't need to stream that much data. So cellular IoT can be a very suitable technology. So I hear you ask, why now? Like what's different now, and why this is an interesting time to start with cellular IoT? Well, there are few interesting developments in the market. And the first one is that many mobile operators, they announced to sunset their 2 and 3G networks. And this is mostly to free up resources, free up frequency spectrum to utilize this in 5G networks or additional 4G networks. And this is an interesting thing because often when operators decide to sunset, to terminate their 2 and 3G networks, they at the same time decide to roll out their narrowband or LTM technologies. And that's also why you see that many modem manufacturers, they provide these cellular modems and they provide multiple technologies on the same modem. So you see that often narrowband IoT and LTM is combined with 2 or 3G. And in that sense, you can deploy it to countries where maybe as of now, no LTM network is deployed, but they might still have a 2G network running. And with the promise that once these 2G networks are being sunset, then these LTM networks can take over. So that's the first interesting development. Another one is that this is a bit of a personal interpretation. So this might not be any hard facts, but I don't see that unlicensed LP1 is living up to their promise. And you can look at Sigfox, which is like one of the big competing technologies of cellular IoT. So they recently filed for bankruptcy. And fortunately, last week, there was a company that acquired Sigfox and preventing them from going fully bankrupt. But kind of their big promise they made in the beginning that is not so much seen in the market anymore. And also Bouygues Telecom, which is a French operator that runs a LoRaWAN network, they also recently announced to shut down their LoRaWAN services and only focus on LTM and narrowband IoT. And I don't say that there's no room for the other technologies. And I'm a true believer that LoRaWAN has a very interesting niche market that they can focus on, but I believe this is mostly focused on private networks, not so much in public networks. And then at the same time, we see that these licensed LP1 networks, which is LTM and narrowband IoT, they are being rolled out at a very fast pace. And also the hardware to access those networks become more and more available for more competitive pricing. So then what's the architecture look like? Well, it all starts with what we call UE, or user equipment. And that's the sensor with a cellular communication module. And in most IoT use cases, we see that the end device or the UE, they initiate the communication. And then the data is sent through the air and is picked up by cell towers, or what we call eNode Bs. Sometimes also referred to base stations. And these base stations are merely the bridge between those physical radio signals and the digitalized world where the data is offloaded to the cloud. And then the core network, so that's something we run as Monogoto. The core network, they do all the device management and they route the data from your end device to the cloud platform that you set up. Which can be a local database or an IoT cloud platform. And in this developer program, we are using the Solexara development kit. So some of you might even be lucky to receive one of these development kits at their doorstep. But I'll be using this kit to give all the examples and all the demonstrations, which is a very tiny development kit that includes a u-blox cellular modem. And the beauty of Monogoto is that we roam with over 500 networks globally. So you can choose your operator of choice, which is, I know, has the best coverage in your area to use their cell towers or to use their eNode Bs. And I'm going to explain you later on how this process works with Monogoto and to manage your devices. And later on at the final week, I'm going to highlight how to get the data from your device into an IoT cloud platform, which in this case is Ubidots. So I think it's important that everyone has a bit of an understanding how these different technologies relate to one another. And as I mentioned before, different technologies, they have different feature sets. And hereby I give you a very rough overview, and Amir later on will dive more into details. And we can see that if you look at throughput, that LTE CAT-M1 is by far the best. You see that can go up to 10 megabits per second, whereas LTM and narrowband IoT, LTM in most cases it's peaked at 300 kilobits, and narrowband IoT is often 60 kilobits. I think in a narrowband, the second version, it goes up to 160, but the throughput is very, very low. If you look at power consumption, then what's also very clear. So narrowband IoT consumes the least power, and LTE CAT-M1 the most. And also that applies to the module cost. And as of now, as far as I know, CAT-M1 still has the most expensive modules because it also consumes most resources to process and send kind of the larger bits of data. But honestly, the biggest reason why people still go for LTE CAT-M1 is because it's such an old technology. It was introduced in 2008, so it has by far the best coverage compared to LTM and narrowband IoT. But this will, of course, rapidly change. But if you truly want coverage in, let's say, the far corners of the world, then LTE CAT-M1 is probably your best choice. And it's good to understand that narrowband IoT, in theory, it works, but I haven't seen it work in practice, that roaming doesn't work, and it doesn't work with mobile devices. And the reason is that it doesn't support cell handover. So if you move from one place to the other, then along the way, you need to switch cell towers, and like that process is not streamlined with narrowband IoT. And here I'm also giving the comparison with the 2 and 3G technologies. And there we also see that, well, the throughput, 2G is very little, 3G is actually much higher, a bit comparable to CAT-M1. Power consumption, somewhat comparable as well. And I think the coverage, that's good to know, in most cases still relatively good, but it is declining very rapidly. So that's something important to keep in mind. So I hope I gave you a bit of a basic understanding of how all these different technologies coexist. And hereby I want to give the floor to Amir. And let me stop my screen share, allowing Amir to take over. In a moment.
Lawrence will be available for your answer in a moment. Okay, so be patient and he will answer all your questions.
Yeah, I see already some questions appearing in the chat, which is really nice. So almost ready to stop my screen share, and then here can take over.
So I'm the VP of Origin GPS. Nice to meet you, everybody. I will talk about all the coverage that we have all around the world over the cellular communication, the Sigfox, the LoRaWAN. There is a lot of variation. There is also the Wi-Fi and the Bluetooth, but the most concerning one is to talk about what really we want to use for IoT device. And in a moment we will start when we stop the sharing screen. So meanwhile, before we stop the sharing screen, Mm. Okay, I'm stopping your screen.
Yeah, please go ahead.
Yes, yes. Mm-mm. Okay. So, Origin GPS and Monogoto are partners. Yes, you are correct. We are buying the Monogoto SIM cards from them to use it worldwide. Just name the place, the country, the location, and Monogoto is working over there. Asia, Australia, South Africa, United States, Mexico, 2G, 3G, CAT-M, okay? It's working. Believe me, we already tested. So, IoT device, what for? What kind of project? What we can use it for? So, as we started 5 years ago over in the GPS, we found out there's a lot of customers want to build their own projects. So as you can see, you can build a pallet tracker, you can build a container tracker, fishing cat tracker, athlete tracker, gun control, just naming it, you can do it because the IoT is so small those days. Because of the form factor of the CAT-M, you can do whatever you want. You can put it over your pants, inside the watch, as you know already once. Let's see the Samsung watch, the Apple watch, you have already over there a solar machine. So eventually you can build any kind of project over IoT device and it working with a very tiny battery. So you just need to think out of the box. Think about project, doesn't matter which one. Also a dog tracker, okay? I believe there is more than thousands of dog trackers around the world. So AI application, everything. Think about it and go build it because everything is possible. And the most important one, use the Monogoto SIM cards. Other ones won't work as this does work, okay, worldwide. You need to think about roaming, you need to think about moving it around countries. This is the point. So if you're talking about the point, moving data from one place to another, let's do this a graph. We can see that we have the wireless, the Wi-Fi 2.5, the 2.4G. You have the LoRa one if you want to name it. We have the Sigfox, LTM, CAT-M, Narrowband IoT, and LTE-1, CAT-1 or CAT-1 bis. Okay, it depends over the release that we have over the countries. So as you can see, the range of the communication between each one of them is extremely huge because the Wi-Fi, it's approximately 100 to 200 meters. The lower range can get to 15 kilometers, but this is over open air with no obstacle. If you're talking about obstacle building something like this, it could be around 2 to 3 kilometers, and it does not have any kind of roaming or an handover, which means it can connect only to one router at the same time. Okay, you cannot do such of handover or mobility with this kind. Sigfox is the most large range zone. It can get more than 50 kilometers, okay? But again, over open air without any obstacles. And still doesn't have any kind of mobility, cannot do any kind of handover. It's need to connect to other of its kind. But if we are talking about cellular communication, it's a other world totally because let's take the CAT-M. CAT-M, yes, its range is 13 kilometers less the LoRa and the Sigfox, but it has a mobility, which means if you want to move to other location, okay, you don't need to disconnect or reconnect to another a cell tower. It's do it automatically because this is cellular repeaters. So just move to one to another and that's it. Also, if it's a mobility over cars that you want to track a car or a package, you can see 100 kilometers and it will still not disconnected for the cell tower. The narrowband IoT, as Lawrence already explained for you, does not have the possibility of mobility or handover or roaming. Right now, release 14 of the 3GPP does not support the handover zone or mobility. It does support the roaming SIM card, but right now what we have over the worldwide, it cannot work as promised. So we will put it aside, but anyhow, the narrowband can get a efficiency when we are talking about low power zone, and Lawrence will explain you at other sessions. The LTE CAT-M1, same as the CAT-M1, okay, have mobility and everything. It supports more variety of mobility tracking, around 250 kilometers. I believe it can get more than this, but I don't believe that someone check it. And its speed of throughput, as already Lawrence showed you, it's around 10 megabit per second, so it can stream video, okay? But you need to understand, when you are talking about 1 megabit per second or 10 megabit per second, it really depends on which protocol or layer of network you're talking about. If you're talking about TCP/IP, okay, that needs an acknowledgement, yes, it will be 1 megabit per second for the CAT-M, but you will need to have the server really next to you, around 1 meter, okay, and connected directly with a cable. If you're talking about UDP, you don't need any kind of acknowledge, just send the data, and this is a real 1 megabit per second, okay? And this is depends also over the amount of pings over the network, okay? If it's more than 16 pings from your point to the server, you will get around, I believe, 400 kilobits, okay, per second, and not 1 mega. Same as the CAT-M, it will reduce, but still, if you want to get to those throughputs, you need to work over UDP or to use sort of a HTTP protocol that's riding over a UDP. You can see also the latency of the network. The CAT-M is the most efficient one. If you want to send data, it will send it much more faster than anyone over the network, also faster than the Sigfox LoRa, and it's almost the same as the Wi-Fi. And if you see the Wi-Fi needs to support very high rate latency, because you are using it for to play games over your computer. So think about it, 10 milliseconds over CAT-M, this is pretty amazing. And the other stuff, as already Lawrence talked about, security. Yes, Sigfox and LoRa has security, and it's good. It's AES 128-bit, but it's not enough. Okay, there is nothing as something like 2GP that give you a certification that it's really secured. 3GPP give you the ability of the cellular communication protocol that is already secured, and on top of it you have 256 AES and also other kind of ciphering that are not explaining over here, but it's much more secure than Sigfox and LoRa, no matter what you do. Okay, this is an hardware certification ciphering and not software. When you're talking about AES, this is also hardware, but in the meantime, you need to use a software in order to build the ciphering over your data. And power efficiency, yes, Sigfox and LoRa are much more high efficiency, but this is because of the latency. This is because of the Bluetooth, okay? So you need to understand what exactly you want to do. If you want mobility, if you want to send data fast, if you want to use it worldwide, okay? There is a lot of things you need to do. But when you are talking about IoT device, this need to be worldwide. This need to be mobility, because if you don't want it to be mobility, use Wi-Fi. Take your computer, it's a big IoT device, put it next to you and send more data you want to use, okay? If you want an IoT, real IoT device, you need to use cellular communication and the Monogoto SIM cards. Also, Sigfox LoRa has only amount of number of devices that can connect to the same router. When we are talking about network, cellular communication, it depends over the coverage, over the cell tower around you, okay? And as you know, over 5 to 10 kilometers, you can get more than 2 to 3 cells around you, and each cell can get more than 1 million users. So do your calculation, okay? Yes, the price is higher for the mobility and everything, but it's not like extremely higher, because if you want to put one IoT device and not 10 because you need to put it at same places, I think it's coverage everything you need. Also, okay, and also the quality assurance of the cellular, it's protected by the 3GPP and other certification. Let's say the Verizon, the T-Mobile, the Orange. It's a Europe and United States over those provider certification for each one of them. So you are protected when you are using a cellular device. Why to use LTE CAT-M also? It has a very low power consumption. It has a unique extended discontinued reception, which means that when you want to drop to a low power consumption, you don't need to disconnect from the network. You can say to the network, you know what, wait for me for, let's say, 3 minutes. I will put my head to sleep a little bit. And when I wakes up, you need to know that I'm over here connected to you. I don't want to search for you. I don't want to let you know that I'm here. You need to know that I'm waiting for you. And this is what EDRX is standing for. It's standing for, I'm going to sleep. You need to wait for me. I'm not going to search for you. So when you are doing it, you are saving a lot of power consumption. You don't need to search for a cell. You don't need to re-register to the provider that you want to send the data. You just need to wake up, bam, and send the data toward your server, and that's it. So you're saving a lot of power at these stages. One more thing. Let's say that you do want to go to sleep. You want to turn off the device and still say to the cell tower, I'm going to sleep, but this time not for a few minutes. I want to go to sleep to 2 hours. It's possible. And this time, still, you don't need to search for the cell. You are saying again to the cell tower, I'm going to sleep, wait for me. This time, you are disconnecting, but you don't need to search for it. You know that when you're going to wake up, you are waking up, you have the same person, the same cell tower next to you, you just registering again, and then you can send the data. When I'm saying searching for the cell, let's say that you have around you 4 providers, but those 4 providers, you have each one of them 4 cells around you. If you take a multiple of that, it's around 16 cells, okay? And this is a minimum, okay? And you just need to search about those 16 cells, which one is the right one to connect to. It can take around 20 to 30 seconds to search for this cell. And when you are searching for this cell, you are consuming a lot of power, okay? It can get more than 150 milliamps, and you don't want to do it. So Origin IoT. Origin IoT has also an IoT device, okay, with the connectivity and everything on top of it. If you want to build an IoT device, what we really need? We need a cellular communication, as we talked about, that support CAT-M, CAT-1, 3G, 2G, narrowband, whatever you want. You need a SIM card. So you can see on top of it a SIM card holder for the traditional one, or you can use an embedded SIM card, okay, if you want to use a lot of devices and you don't want to inject each one manually and you want to do it over the production line. It's also possible. You just need to ask for Monogoto an embedded SIM card. Also, for the later on, at the same connectivity module, you can inject an eSIM. eSIM means that over the embedded chip inside the communication module, you can inject the key of the SIM card, and that's it. You don't need any kind of plastic SIM card. You don't need a chip for SIM card. Everything is inside the same module for the communication, and you are saving place. Also, you can use an external GNSS module if you want to work at parallel to get also location at the same time that you're connected. As you can see right here, you have a module of a GNSS, and beneath it you have the module of the GSM, which means there is no interference between the RF chain. If RF chain has its own antenna, and they are working in parallel with no any kind of interference. Okay, this is get around 1 meter accuracy location. This is wow, and we are working at those GNSS fixed location. Also, we can work with external MCU. As you can see, there is an Origin Smart firmware inside that can join everything together. The SIM card, the Gemalto cellular communication part, the GNSS part, and also you have an external GPIO, okay, to connect any kind of sensor that you want. If you want to connect I2C, SPI, UART, just name it and you can connect on top of it, and you don't need to write any kind of embedded code. Everything is writing from the cloud. This is what's smart about the Origin Smart. You don't need to code anything. Just connect an antenna on top of it that we have at Origin GPS with 9-door, with power manager, with DC-DC, with connector to battery. Okay, plug it in together like a Lego, okay, with the antenna, and bam, you are good to go as IoT product to the air, and just put it in any kind of enclosures that you want. It shortens your time to market because you don't need any kind of engineering for a firmware, for a RF designer. You don't need a PCB designer, nothing. You have the world's small footprint of this kind. As I said already, it doesn't have any kind of interference because it has superior GNSS and cellular matching. The lowest power consumption because this is using the CAT-M, as I already talked about. No additional embedded code. Everything is from the dashboard itself. So what you actually need to build an IoT project. So you need the IoT itself, as you can see. Okay. You will need an add-on, which means you need a sensor. What kind of sensor? If you want a gyrometer, barometer, magnetometer, temperature, a motor control, a DOF, just name it, connect it. You need to look for what exactly you want to do with the IoT, what exactly sensor you want to connect to IoT in order to build your project. This is what really matters, what you want to do, and choose the right sensor for it. The antennas. You need to select the right antenna because when you're connected worldwide, you need to think about all the frequency in order to connect from 600 megahertz until 4 gigahertz. And you also need to connect the correct antenna for the GNSS in order to have the right gain to get the fixed location, because each enclosure gives you a, 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 a complete a different solution for the GNSS. Choose the correct battery, which means you need to calculate how many times you want to connect to the dashboard, how many times you want to gather the information from the sensor itself. So at the bottom line, you need to calculate the capacity of the battery and then start to search the dimensions of the battery. The most important one, don't forget to use Monogoto SIM card. Without it, you won't be connected to anything, okay? This is the most important. Once you build all those additionals around you, the add-on, the antenna, the battery, the SIM, you need to place everything together in something. This is called an enclosure. You need to build a correct enclosure for your project in order to build it. You finished it, you want the user to use it. So you need to build a dashboard, and over the dashboard, the user can build and see over the gadgets, over the information of the logs, what exactly going on with the IoT itself. And after it, you have a complete solution of a project, okay? A smart padlock, the same IoT device, but with a change of the battery, external sensor, motors, and everything is working. So what we really have inside, it doesn't really matter. What matters is to know what you want to do, what is the right sensor to build an IoT device, how to build it, how to complete a complete project, okay? How to build a GUI for the user. So Origin IoT gives a full dimension for it, an end-to-end solution. Let's take an example for one of our IoT customer inside Israel wants to build a tracker for tortoise, okay? You know how small these animals, so it must have very small and very light. So the IoT solutions that we gave to this company was only weight less than 40 grams. 40 grams, battery, antennas, IoT, and enclosures all together in the same size and weight. Another customer, we want to track athlete tracker in real time. So we built a tracker that the athlete puts in the belts beneath them, okay? And we can track whatever they do in a real-time transmission, okay? With no problem, with the sensors that we have, the gyrometer, accelerometer, magnometer, okay? And with the batteries that we have selected to this project, it could live for 15 hours in real-time transmission. The last one, the most important one for everybody around the world, is the dog tracker. Everybody wants to track their dog or their pet. So another one, he has selected to build an enclosure that look like a bone, as you can see. You have it, and as you can see, it's only weight 20 grams. 20 grams with battery and enclosure. So you need to think about a project. Doesn't matter which one, but eventually what you need to do is to know what is the project about, what kind of sensor you are going to use, okay? And how many times you want to see the data over the year. When you have those answers, you can build a project. But I have not finished. I want to show you how it's really like in a real life. Give me 1 second. I will stop my virtual background. I will stop screen sharing. Hello, everybody. It's me and Lawrence together right now. So you already saw the padlock. This is the padlock in real life, running and walking. But where is the IoT? How can it fit inside this one? So the IoT is this device. Just a moment, let me do a trick. Is this device. As you can see, it's really small, really tiny. See my fingers, sorry about. Once you have this IoT device, all you have to do is connect an add-on with a battery. You just need to select what exactly you want to put, which kind of battery, which kind of enclosure, and that's it. And if you want to see a full project solution with antenna, with everything, as you can see, it's connect, it's live and working, and it's all can fit in this kind of box. This is the tortoise box, okay, that weighs only 30 grams, okay, with the battery, with the antenna, with everything. Just put it on over the tortoise and you can track it. Thank you very much, everybody. I will hand over as a CAT-M to Lawrence.
Perfect. Thank you so much, Amir. It's great to see how this all works together. And yeah, it's true. I've already seen a lot of dog trackers in the market, but I've never seen this tortoise tracker. So that's really, really fascinating. So I have a few final slides, and then I would love to go over and highlight the different questions that people already asked. So I often hear questions, okay, so like, can I already use it? Is it in my region already? And I think there's already a question here whether it's available in Kenya. And fact is that it's 110 operators claim to have narrowband or LTM networks available in their country. So the world map looks a bit like this. And of course, if you look at India or Australia, of course, not the whole country is covered. And it is mostly centered around the bigger cities, but like the networks are really being rolled out at a fast pace. And once you start connecting your network, and let me share with you some information about Monogoto itself. So Monogoto is what we call an MVNO, so a mobile virtual network operator. And it means that we take care of the full network, the device management and data routing. So we take care of the full chain except for the physical infrastructure. So we collaborate with local partners, local mobile operators. So we have about there are over 500 networks that we work with across about 180 countries that we work with. And you have one SIM, and then it automatically works with all of these operators. And the interesting thing is, so the majority of our work is focusing on these public networks, allowing you to connect with their cell towers. But we also support customers in running private networks. And it means if you have an interesting use case in your area, then you can set up and fully manage a private LTE network. And the beauty is you then can suddenly start to run your application, what we call hybrid. So if you're within your vicinity, then you can use your own private network. And once you leave your region that contains your private network, then you start using the roaming features of Monogoto. And developers mostly like our platform because it's all developer friendly. We have a full API first design. We try to embed the cloud best practices. And I would love to show you more how this works in practice during next week's sessions. But basically what it means is we have a very intuitive console as well as a hub to manage and monitor your SIMs and your connected things. So you can see the status, but also you can initiate alerts and triggers. You can create integrations with, for example, Slack or anything that you custom build to also receive notifications if you pass a certain amount of data within a certain defined area. And the beauty is it's all fully customizable. And we have a graphical user interface, but you don't have to use it because you can fully integrate our services in your platform of choice because everything is API driven. So we're slowly nearing the end of this presentation. And I already see that there's a lot of questions that came in. There might be too many that I can answer, that we can answer at this moment, but so therefore I warmly invite you to engage on our forum. So I'll be there. There are more support engineers, experts of Monogoto willing to help everyone. There we share important updates, and mostly we want to bring the IoT developer community together to share each other's struggles and to really help each other out in this challenging world of IoT. And also the documentation page is constantly in development. So warmly invite you to have a look there to see how you can start working with Monogoto. So there's a device configuration page, and if you click the drop down, and you can also find out how to use the uBlocks that some of you may have received and really to start working it. And yeah, that was almost the end of the first session. So next week we're back, and I'm actually really excited for next week because then there will be less talking and more doing. So I'm going to demonstrate how everything fits together, from programming cellular IoT devices using AT modems to how to utilize the API from Monogoto, and eventually to have data appear in the cloud. And yeah, that's everything for now. So thank you so much for tuning in. It's really been great having this presentation and to see the many people joining the conversation. So yeah, let's jump into some of the questions that people have been asking. And actually, I would love to ask you, Amir, the first question. And so you've been in this field for quite some years now, and for sure you've made tons of mistakes along the way. So if you would point out one specific thing that you would say that you want to help developers and prevent developers from making that same mistake, what would that be?
Wow. First of all, there is a lot of things to think about when you're building a project, but the most important one is to know what exactly you want to do. Not to say I want an IoT device and I want it to be a dog tracker. No, you need to be very specific at your demands, because if you want to build a project and you don't want to waste your time, okay, and of course not to waste your money, because each kind of this project wastes a lot of time and a lot of money, you need to be specific regarding exactly what it needs to do at the end. Because let's say that you want a dog tracker, and as we know, there is a lot of them around the world. Let's be a little bit more efficient, and let's be a little bit with more open mind, because you can build an AI for the dog, you can build an AI for the dogs one it's barking, so you put a microphone in order to know what when it barks, how it barks, and what exactly does the dogs means. Okay, this one doesn't have around the world, so let's put a microphone, an AI, and then we have a new project for an IoT device. Not just saying let's track the dog, because tracking a dog, it's something simpler. You have it all around the world. Okay, so you need to think outside the box and to know exactly what you want to do, because otherwise you will spend your money and your time for nothing.
All right, so really narrow down the scope of what you want to accomplish. Nice. So I saw a few questions. So because of the time, I'm going to try to answer a few in a relatively short time. So I saw something from Aksha Han. The cloud is integrated, or can it be configured for other cloud services as well? So this is actually one of the parts that I'm going to explain with you, explain next week, is so you can define your own endpoints. And so if you will assume we're gonna use Monogoto as the cloud provider, so they do all, let's say, the core network and the network handling, but you can define any endpoint that you like. So you can connect it to your local server or any cloud service like AWS or Ubi. That's what we're gonna explain, what we're gonna showcase in upcoming weeks. So Knight's question about narrowband IoT. So we do support some narrowband IoT networks as of now, but we are actually working on this, and will be more, actually significantly more narrowband IoT networks will be supported later this year. So that depends a bit on your region. So feel free to send me a message, and I can try to help out and provide with you some information if we can already allow you to access that network in your area.
There is one question regarding if Monogoto SIM card has a global coverage. And I want to show an example. Why does Monogoto have a large coverage, more than anybody right now around the world? While we're starting to work with Monogoto, we have other provider of SIM cards of roaming, okay? And we build something very unique, okay, that travel all around the world. What is this something? This something is very big and very expensive. This is a container. So you want to track your container, but do not just track it. You want to know if something happened to it, and you want to know if someone is opened it, try to steal something. We build a container lock for a company that's called Toyota. And inside we have Monogoto SIM cards. And we can say, okay, that this kind of enclosure, okay, this kind of machine is working worldwide. Just name the place, and this kind of lock machine working Australia, South Africa, United States, Mexico, Japan, any kind in your place, okay? China, it's working CAT-M and fallback to 2G. And yes, it's a global coverage for Monogoto.
Great. And I also saw a message about someone from Kenya that LTE network is not yet available there, but we do provide 2, 3, and 4G networks. And you can configure it in such a way, and definitely many IoT applications, these IoT modules that you use, they embed multiple cellular technologies. And like I mentioned before, it often comes with 2G as well as LTM and narrowband IoT technologies. So in that sense, if the one technology is not available, it can start using another one. So Oliver, a question about running private LTE networks. Well, the beauty is you can manage, or you can run it wherever you like. And that means that we are supporting you and providing you the specific hardware, and we support you to set it up yourself. And with private networks, well, the big benefit is that you are in charge of your own quality of service and level of security. And that means that, like you can take care of that. You can manage that only data, for example, stays on your own servers. So we are happy to help you set up this network. So let's have a look. I think there was from Alexandro a question about what do you mean with LoRa and Sigfox about mobility. So you might have more information about this, Amir, but LoRaWAN works very well with mobile networks. But there are, I think the big issue is that there are many, that there are not a lot of networks that have a very good dense coverage in whole country or in like the whole Europe, let's say. And there are also not that many roaming agreements between LoRaWAN network servers.
This is a problem.
Yeah, so it may work very well. Let's say KPN has a very good network in the Netherlands, but then once you cross the border with Germany, then there's no coverage because there are no roaming agreements. They might have some agreements in France, but then you have to be lucky. And Sigfox, maybe you want to reply to that, Amir?
Right now, as I tested, I haven't seen something that has the mobility of a Sigfox because it's working very of a high range density. So I don't believe that someone really needs it because Sigfox is used for very specific sensors, okay, for fields, okay, for how it called agriculture sensors, most of them, as I saw. So I haven't seen any kind of mobility in Sigfox.
Yeah, and what I know about Sigfox is, so they have a lot of issues if, so it can use for mobile devices, but it's not very suitable for a device on the move.
Yes.
And therefore it appears to be not very reliable. So love your question, Ronald. So I'm currently working on an IoT-based customer experience rating system. My next step is to find out the way to connect all my devices to batteries and then use ultra low power modes. So this is great because we're going to dive into aspect in the 3rd week of this series. So which technology for communication do you recommend for this use case? That's hard to say because I think a crucial element here is where are you planning to deploy those devices? and then have a look whether these networks are available and of high quality in these areas. But I would say any of the three networks or technology would work well, but probably LTM or narrowband IoT might be the most suitable because they are most consume the least energy. But if it's in a very remote place, then CAT-M1 might also be a valid option if you really want to make sure that there's decent coverage. But yeah, again, happy to think along. So drop me a message or initiate something on the forum, and we can think along together. Good. So
there is Timothy. Sorry to interrupt you. Timothy Carter. How can we reach out to the GPS to contract our design? Just go to the website. There is a panel that you can put your project with everything that you need, where you want to connect, how do you want to connect, which kind of sensor. Put it there, or just contact us in there of the email, and we will contact you directly. There is another one that I've answered him incorrectly from Jacob. Is there any restriction on enclosure material in context connection strands? Of course. It depends if it's plastic, which plastic, ABS or a polycarbonate, if it's metal, aluminum or steel. It's really depend, and we are doing also simulation for the reception of the GNSS and the cellular in order to get the best reception and transmission for the projects that you need. Laurence, back to you.
Thank you. I see a few questions about the SIMs or about the SIMs and the development kits. So we did manage to send a few development kits, but we were very limited in the amount of kits we could send out. So only the lucky few received one. And the others that did not receive a SIM, they did not receive a development kit, they can still receive a SIM. For that, you might have already received an email from me, and if not, feel free to reach out. There were a lot of last minute signups, so if you sign up, let's say a day or a few days before, then I might not have been able to get in touch with you. But yeah, for sure, happy to send over a SIM so you can really experience how everything works firsthand. And I believe there was one more question about the antennas and whether it's also possible to have a integrated or internal antenna. Well, I think this is a good question for you, Amir.
Yes, everything is possible. At this world, everything is possible, but you need to know if it's internal antenna, okay, you won't get a good reception because you will need a very large ground plane over the PCB to get a good reception, okay? But if you put an external antenna, okay, it has its own place, okay, to get all the reception to it. Also, for GNSS, you need to use a ceramic antenna to get a good reception, and you need to be a little bit large, around 14 to 14 millimeter. This is the minimum in order to get a good reception. For the cellular, it really depends over the frequency and the bands that you want to use. If you want to use worldwide, you will need to use a very large antenna in order to support the lower bands or the lower frequency, like band 28. This is the most used one over Australia. Right now it's also in Israel. I believe it's also at Europe. This is using the 650 megahertz frequency over band 28. And yes, the question, I believe that the external one is much better than the internal. But as I saw from the SODAC, you have also an internal antenna for the cellular and external for the GNSS.
Yeah, so as you can hear, if you talk about antennas, it gets technical really fast. And so I think to learn more, I think they can always reach out to you or start a discussion on the forum.
Yes.
because this is a really interesting topic. We even also have now a new company which is called Ignion, and they really focus on having these integrated antennas and using the PCB itself as the ground plane, making these whole antenna placements more consume less resources in terms of space. And then I want to end with the final question from Timothy, because we are running over time badly. And he had a question about recommended alternatives to GPS. Well, here there are different options. It also depends on the location and the accuracy you need. And for example, one of the good things about cellular communication is that you can track the specific cell towers that your device is using, and then you can have a rough indication of where your device is located. But given the fact that the range of these devices are can be very large, then you never know where your device is located actually. So it can be a few hundred or maybe even kilometers out of range. I'm here.
There is one more solution that not everybody knows about it. It's called Google. And Monogoto can give you this kind of solution, okay, but you will need to pay it an extended payment, okay. They can build a mechanism that talking with Google APIs, okay, to see who else over Android phones that using Google machinery, okay, are connected to the same cell tower, and they are doing a triangulation not just with the cell tower, also with the same UE. If it's a IoT devices, if it's a cellular machine like your phone, so it will be best if you don't want to use a GPS. But the best option, as Lauren says, is a GPS. You can get as a one fixed meter point.
Yeah, but this is a good point. So I think with these Google APIs that for example works very well with Wi-Fi or Bluetooth. So you can actually embed a Wi-Fi chip on your IoT device, which is actually much cheaper and less power hungry than a GPS modem.
Yes.
And that way it kind of sniffs the Bluetooth beacons from the different phones around you. And with the Google API, you can, in that sense, retrieve your GPS signal. So it can either sniff the mobile phones, for example, but also looks at the Wi-Fi signals in range. So you can track kind of the Wi-Fi access points, which apparently work very well in cities. So I want to keep it at this. So thank you so much for joining in. It was a great honor presenting to you, and definitely a big shout out to Amir. Very nice having your expertise here. I'm going to share with you the presentation probably by tomorrow, so you receive an email. And so I'd love to see you all back on the forum, as well as next week during our upcoming developer workshop. Thank you so much.
Thank you very much, guys.